Okay, so here is the review for Tribonacci. But first, let's just peek at some test cases. I'm just going to return 0, see that they're all wrong. Cool. And let's start by coding up our base cases. The first 3 Tribonacci numbers are 1, 1, and 2. The fourth is 4. So let's code this up. If the person asks for the very first Tribonacci number, I need to tell them that it is 1. Oops. I guess we'll have return 0 down here as a placeholder. Cool. So I passed the first test case that says the first Tribonacci number is 1. I continue that pattern. The second Fibonacci number, or Tribonacci number, is also 1. Okay, another test case pass. Then, if they ask for a third Tribonacci number, that's going to be 2. Okay. Else, well, I guess we can code it up like they do on the AP test. We can just put our recursive stuff here. If they request anything else that's position 3 or higher, we have to call the function based on itself. So that looks like tribonacci of n minus 1 plus tribonacci, we're still adding, yep, tribonacci of n minus 2. So at the moment, this only adds the previous 2. Notice when we get to Tribonacci of 3, it adds up. Tribonacci of 3 takes 2, adds it to 1, returns 3. But you also should be adding 1 from Tribonacci 0. That's what it's missing right now. Go through another example. Tribonacci of 4 adds up 3 and 2 to give you 5. But it should be adding up 1 more from before. It's already adding up like all these wrong answers. It should be adding up 2, 3, 1, and 1. Gives you 7. Why is that right? I expected it to be wrong. Did I add up wrong? Strange. So on and so forth. So far as written, we've added a new base case. It's your job to make 1 more recursive call to Tribonacci here that adds up 3 numbers behind where you're currently at. Does that help? Something more needs to happen right there to be more direct. Okay. Now, BunnyEars2. I have Block 6's video on this, but I can explain it once more. So here we have 2-eared bunnies as normal, and then every other position, the even positions, we have 3-eared bunnies because they're sticking up a foot, and we're counting that as an ear. It looks like an ear. So in the beginning, we can code this up assuming they're all 2-eared. If, and then we think about our base case. Let's take a look at the code. What is the base case? Is it 0 bunnies or 1 bunny? 0 bunnies, cool. So if we have no bunnies, we return 0. If bunnies equals 0, return 0. Otherwise, the recursive stuff, we have to count by 2 and then add up all the bunnies that came before it of n minus 1. So think back to that picture of the people counting themselves in line, saying me and the guy before me and the guy before me, me and the guy before me. That's what's happening in this line right here. 2 ears for the bunny that you're at, plus all the bunnies that came before you. This one should add it 2 by 2. Messed up somewhere. Oh, bunnies minus 1. Right? So this just counts by 2s. Now we have to count by 3s every so often. So now we have to check some odd and even. And when you think about odd and even, your brain should be drawn towards mod, the remainder function, whether or not things are divisible by 1 or 2. So these are the positions currently that will be odd positioned bunnies. Bunnies with 2 ears. We can leave an else statement here that will cover the even positioned bunnies with 3 ears. So we take a guess. What should go here? And what should go here? I guess I'll code up the first part. This one should be odd, right? So wherever we're at, bunnies, our current position, divided by, or odd 2. If we have a remainder, that means we're odd positioned. I want this code to work, so maybe here I'll just return 0. Okay, this one doesn't deal with these cases yet. We're not adding in 3-eared bunnies. So the first part of this code looks like 3 plus. Okay, this one should be able to get the first test case. Nope, not even. We stop short. So in this one, to understand what's going on, right now we're just returning 3. We're not considering all the bunnies that came before us. It's like a hard stop. So we need a recursive part that goes here. Anyone have some ideas on what should go there? Yes, no? Cool. One student's got it. Let's type it in. So this is the part, again, like the original bunny ears problem, where you look and add up all the bunnies that came before you. You need the recursive bit. You're adding 3 for the current bunny, but don't stop just yet. You need this bunch. And we're done. Kind of neat. 2, I guess, branches of recursion based on your position. Add 2 or add 3. And we still loop. We still progress through our function recursively. Neat. So we talked about this one. I gave you hints for Tribonacci. We reviewed BunnyEars2. I guess at this point, since there's no other request, I can go through some slides giving you some tips on the recursion 2 problem set. And on Monday, we begin our new topic of 2D arrays. It's like moving around in a grid. And we will introduce the game of life assignments. So due on Wednesday are all these things. Be sure you get them in. If you get them in, if you turn them in to me on Wednesday, I have no guarantee that they'll be graded in time for when grades are due. So best you turn it in over the weekend or today, so it leaves me plenty of time to grade it. Talked about head and tail recursion. Here's a nice little comic if I haven't shown you already. Pooh is eating recursion. I have a couple hints on some digits. If you need help with it, here are some, I guess, notes on some digits. I also have a video going through the 126 example on what your code should be doing. So these next couple ones, count 7, power n, comes from recursion 2. Count 7, power n. In block 1's video, I talk about count 8, but I kind of stop. We don't arrive at a complete answer just yet, but we're pretty close. So in count 7, this one, very easy to solve with a loop. However, you're working with recursion now. You need to use mod and you need to use integer division to help you isolate single digits in count 7. And then count 8, it's pretty much the same problem, except they add in a special rule where adjacent 8s, so the number 88 gets counts twice. Power n, take a look. It's the exponent function. You've coded this up once before using a loop. Now you got to do it recursively. And these last couple ones go over a string. You travel through a string recursively. So you've done so with loop before. You examine characters of a string one character at a time. And you'll be asked to do so, but now with recursion. As like before, you have to remember a couple things, right? You need a base case, you need some recursive stuff. So here, a related program, we're trying to write a program that counts through all the lowercase a's present in a string. You should be thinking about 3 test cases. First, if your string is empty, for sure you return 0, as empty string does not have any lowercase a's inside of it. The recursive stuff comes a little different. First you think about, okay, is the letter that you're currently at the letter A? If so, you have to count, right? Increase your count by 1, and then throw in all the letters either before or after you. Like, throw those in to be processed. Then if your first letter isn't A, you add nothing, and then do some recursion. So take a look at this code segment. Notice that here, word.substring1, that returns everything, including position 1, to the very end. Remember the 1 argument version of substring versus 2. So as written, this code counts through a given string and finds out the number of little a's inside of it. It uses character at. You could have also used substring with 2 arguments to isolate 1 character at a time. Hey Gui, try character at. I wonder if it's a difference between character at and substring. Something worth trying. I don't know if there's something very subtle that's different about them. So notice how we would change this to check for things like lowercase b. You can imagine the stuff that changes is just this part over here, that character. Oh, sorry, I read the problem wrong. We are replacing a's with lowercase b's, not just counting. So replace as, I don't know if we, well actually, yeah, okay, so this one we have to use our substring to help us process. And instead of adding 1, look here, we're putting strings together. The other parts look the same. Right, so it's this part here that changes. There were some highlights, right? Previously we were adding 1 and 0, but when we're doing replacing, we are adding 1, or we are replacing b and leaving it alone. That's what word.substring 0 and 1 does. If it isn't the letter A, leave it alone. So these coding, these little hints should be useful for the later couple problems in your coding bat problem set recursion 2. Do I have anything else? It works, Squee? No work, okay. So probably I'll talk with Mr. Simon. We should be meeting today. So there seems to be a bug with one of the test cases in the coding bat 2 problem set. We're looking into it. So I got 7 more minutes. We have one last question over here to talk about, unless there's more requests for coding bat problems to be reviewed. Any requests? No? Then let's solve this practice quiz question. I think at the moment, Jack, we are having problems with change xy. Something's up. Here, I'll message you the code, and let's see if we can find what's wrong. It works for some of the test cases, but specific ones, we think the output is wrong, the expected one. Okay, so practice quiz question. It kind of uses the ideas of head and tail recursion we talked about earlier this week. Give you maybe 2 minutes to think through it, then it leaves me 3 minutes to explain, possibly dismiss you early. Cool. So let's go over this problem. Got 2 minutes. Let's go. Hope I make it. So head tail of 1. For ease, I'm just going to use h to represent this function, h of 4. H of 1, we're counting up. Gosh. H of 1. So h of 1 is not the base case. So we recurse, we print out 1, then we will print out the recursive stuff. H of 2 gets called, and then 1s are like sandwiching the output from h of 2, right? H of 2, what happens there is the number 2 should be printed plus the output of h of 3, okay, and then number 2 is printed again. Then h of 3, you can imagine this pattern continues. There's some sandwiching happening. 3 gets printed, and then whatever is in h of 4 plus a 3 again. H of 4, we can now print out the word base case and return. So now h of 3 gives you 3 base case and then 3. Then h of 2 adds in those other 2's to the left and the right. H of 1 returns those 1's at the left and the right. So yeah, 1, 2, 3, base case, 3, 2, 1. There's both head and tail kinds of recursion happening here. Yeah, be careful. And again, like, we don't often work with print. By not having print line there, it all prints on the same line. By having the add and the comma, I guess I'm missing my commas, right? It all looks like one nice sequence. Even at the end, there's a comma at the end. So that's your final output. I think this is as hard as the recursion gets. Right, 9:36. Sorry for keeping you. That's it for today. Turn in your stuff. Email me for help. If you need to meet for office hours, turn in all your work. Have a good Friday. I'll see you on Monday for 2D arrays talk.